Hello, my dear student. Welcome to Exam Prep Tool. If you are preparing for GATE CSE or GATE DA, this is the correct place. 300 questions, 300 quality questions I am going to explain here. Mostly in GATE examinations, questions will come from these 300 questions only. Most of my students every year used to say this only to me. Sir, questions came from your notes. So I'm strongly saying to you, don't miss one question also out of these 300. It will really helpful to you in the examination. You will get a lot of advantage. First of all, myself, I am Subbarao Lingam Gunta. My students used to call me Reddy sir. I have 14 years of teaching experience. I guided more than 25 lakh students. Right? And one more thing I want to say to you, I am from IIT Bombay, right? In computer science department. I am the GATE top ranker. All my team members are IITians. 300 quality questions we made. Don't miss one also. Definitely most of the things will come in the GATE examination. And while seeing this lecture at anywhere, if you find out any doubt, this is our WhatsApp number, right? Message us. This is our WhatsApp number. Please message us, right? Your doubt will be resolved by our team members. Hope this class will be really useful to you. Go ahead. Yeah, in the previous class, I think we done until 43. It is a question number 44, right? So please read it. This problem belongs to distance vector routing algorithm, and the objective of this particular problem is, right, finding the shortest path from router R to router Q and router P, R to Q and R to P. So if you want, you can see R to P, R to Q, R to P, R to Q. That is the purpose of this particular problem. Distance vector routing algorithm, you know, every router want the table in the best format. Shortest paths will be there. But here we are not doing the total problem. Our goal here is R to Q, what is the shortest path, R to P, what is the shortest path, we are trying to find out. Right? And one more thing is, that is fine. Right? What information already know, let's check here. Assume that R does not initially know the shortest routes from P to Q. R don't know initially what are the R to P, what are the R to Q. Initially you don't know shortest paths. Okay, that's fine. Assume that R has three neighboring routers denoted X, Y and Z. During one iteration, R measures its distances to its neighbors X, Y, Z as 3, 2, 5. Finally, R to P, R to Q is his goal, but right, he knows as of now this only: R to X, R to Y, R to Z. What is the R to X? 3. What is the R to Y? 2. What is the R to Z? 5. In one iteration, he want to finally find this. That is fine, right? But as of now, you know this only. Okay, that is fine. Respectively, that's fine. Next one, router R gets routing vectors from its neighbor that are indicate that the distance to router P from X, Y, Z are 7, 6, 5. Router R gets routing vectors from its neighbor that indicated that the distance to router P from router X, Y, Z are 7, 6, 5. Respectively. The routing vector also indicate that the distance to router Q from X, Y, Z are 4, 6, 8. Right? So please remember, so R will get from the neighbor. These are the distances. Router R gets routing vectors from its neighbors that indicate that the distance to router P from routers X, Y, Z. Right? So let me write now. Distance to router P from routers X, Y, Z are 7, 6, 5. In the similar way, this also x, y, z. This is going to be 4, 6, 8. Right? So R will get this information from their neighbor. R will get this information from their neighbor. Right? Now I think these are the things until now. Which one of the following statements are correct with respect to the new routing table of R? R will get from their neighbor this information. What is that one? Right? So Q2X is 4. Q2Y is 6. Q2Z is 8. And one more. P2X is 7. P2Y is 6. P2Z is 5. Please verify. 7, 6, 5. One more thing is 4, 6, 8. And initial one is going to be 3, 2, 5. What is the 3, 2, 5? What are these people? Right? R to X how much? R to Y how much? R to Z how much? And so on. Now see everyone. Everyone careful. So to go from everyone, listen, to go from all information came to R, right? To go from R to P, how many ways are there? I want to go from R to P. How many ways are there? Let me check. R to X you can go. X to P you can decide. X to P, P to X same. Right? Can I help you now? R to X how much? R to X is 3. One way to come here is R to X is 3. Right? Next one. Right? R to X is 3. That is fine. Right? X to P how much? R to X is 3. X to P how much? X to P is 7. That is the one way. One more going to be, right? R to Y first. R to Y how much? 2. Plus Y to P how much? 6. One more going to be, let me write now. One more going to be R to Z first, 5. Plus Z to P how much? 5. So 3 plus 7 is one possibility, 2 plus 6 is one more possibility, 5 plus 5 is 10. This is the R to P possibilities, right? So R to X, R to X3, X to P, R to Y plus Y to P, R to Z plus Z to P. So finally I think in my opinion 3 plus 7 10, 2 plus 6 8, 5 plus 5 is 10. So 8 is better. 8 is better. How it is? R to Y which is going to be 2. Next one Y to P, how much? Y to P which is going to be 6. So 8 came. This is better. Right? Fine. So that is okay. I think one thing you got. One more thing, let's see. What about Q? Same way. R to X how much? R to X, X to Q. One more thing is R to Y, Y to Q. One more thing is R to Z, Z to Q. So R to X how much? 3. X to Q how much? X to Q 4. So 7. One more. What is the R to Y? R to Y 2. Right? Next one. Y to Q how much? 6. So it is 8. Next one. R to Z how much? 5. Next one. Z to Y how much? So Z to X, Z to Q how much? 8. So it is a 13. So 7, 8, 13. So 7 better. So it is a 7. From where? R to X. R to X, X to Q. Previously R to Y, Y to P. So 8 and 7. So let's check one by one. R to P is 10. No. R to Q is 7. R to Q is 7. True. Next one. The next hop router for the R to P is Y. True. The next hop router for a packet R to Q is Z. No, R to Q is X, everyone know. R to Q is X. So that is the reason wrong. So answer is going to be B and C. Answer is going to be B and C. It's a normal problem. Just he is asking from you, do you know distance vector routing algorithm terminology? Do you know distance vector routing algorithm terminology? Other than this, he is not asking anything. Some information is given, in the next iteration what is the answer is asking, right? So distance vector routing algorithm information is asking. So what you have to do is R to X, X to P, R to Y, Y to P, R to Z, Z to P. Similarly, R to X, X to Q, R to Y, Y to Q, R to Z, Z to Q. Find out these values. Whatever values they are, as it is, right? So if you see in our answer, right, so it is going to be, right, 10, 8, 10, 10, 8, 10, 10, 8, 10. This is next one. If you go to the Q, let's see this one, 7, 8, 13, 7, 8, 13. So this R to X, X to Q, one more R to Y, Y to P, right? This is going to be 8, right? So, and one more thing is going via 8 is okay, via which vertex you are going? Q going via X, right? P going via Y. This is 8 via Y. This is 7 via X, right? That's the answer for this. So answer is going to be B and C. For this problem, answer is going to be B and C. Very simple, you don't need to confuse. Distance vector routing algorithm you study first. Routing algorithm guarantee one question will come in the exam. Routing algorithm, one question guarantee will come in the exam. One is the distance vector routing algorithm, one more link state routing algorithm. These two things will come. Any one will come or both will come combinedly. Terminology only you should know. Just you should know terminology. Right? So one iteration only they will ask. They don't ask you many iterations. Right? Fine. That is fine now. Question number 44, we done it. Go to the question number 45. For 12 subjects of GATE examination, every subject is approximately 200 questions to 300 questions. 300 quality questions were designed. 12 subjects, every subject 200 to 300 quality questions were designed. Approximately 2400 questions to 3600 questions. These many quality questions were designed with video solutions. Mostly in GATE examination, all questions will come from these only. 12 subjects, every subject 200 to 300 questions. Our team is all IIT experts. Myself, as I mentioned to you, 14 years. Most of my students are, right, they're in IIT. Most of my students are there in MNCs, big MNCs. Most of my students are top 100 rankers, top 10 rankers, top 50 rankers. If you solve all these questions, I'm very sure, right? I'm very sure your rank will improve by, right, at least 10 times. Right? Through experience, I'm saying mostly questions will come from, right, these questions only. Don't miss at any cost. Right? So for if you want to subscribe for this course name is called as Rank Improvement Course. Rank Improvement Course for CS, Rank Improvement Course for DA. Right? For admissions, you can WhatsApp me to this particular number, or you can directly go to exampreptool.com. You can subscribe from there also. It is really useful to you. Don't miss at any cost. This is right. Utilize the last 2 months quality time in the quality way. Right? I hope right, you will get a lot of benefit from this. Right? All the best. Yeah, it is very important one. So just let me write roughly what is the TCP state diagram. Roughly I am writing, roughly, right? Roughly I am writing. If you want, I will go to the another slide, right? See this one. TCP state diagram, roughly I am writing. It is the client, TCP client, TCP server side. So initially server is there in the listen state. Listen states. Now sender will send, client will send, right? Right. What he will send? He will say SYN, a connection establishment. He will say ACK plus SYN. He also want to establish connection. So initially client is there in the right SYN sent state. This is going to be SYN received state. With that SYN received state, he will send the ACK plus SYN. He will send ACK plus SYN. He will send, right? Then ACK means established. It is going to be established state. He will send ACK again. It is also established. So then data transformation is going on. After some point of time, client will say, right, FIN, right? So he will send, client will send FIN. Then this state is called as, before sending, this is called as FIN wait state 1, right? Then server will become close wait state, right? Then he will send ACK, then he will send ACK, right? This is going to be FIN wait state 2, FIN wait state 2. This is going to be close wait state. Everything is fine. After some point of time, receiver will send FIN again. Then it is called as close wait state is over. Last ACK state, right? So this state is called as, right? FIN wait state 2 is over. Then this state is called as time wait state. This is called time wait state. Then he will send the ACK, which is going to be, right, closed state, which is going to be closed state. So remember, these two are common, right? Last ACK state, send FIN. Then you will get the time wait state, then he will send ACK. It will become closed state, right? This is already in the classroom we covered. Please go through it one time. Now what is the given problem? Please check. See this. After completing the data transfer, means I think is asking which area. Let me do this. Yeah, after completing data transfer, is the data transfer. After this, I think this area is talking about this area. Yeah, after completing the data transfer, right, the TCP client calls close to terminate the connection, and FIN request is sent to the TCP server, right? Server side TCP response, right? When client sending FIN request, right, client is there in the FIN wait state. After FIN is went, then server is there in the close wait state. Now what is saying? Server side TCP responds by sending ACK, which is received by the client side TCP. Okay, he sent ACK. Then in that state, client is there in the FIN wait state 2. In that one, right? What is asking? As per the TCP connection state diagram RFC 793, it is one of the protocol, right? In which state does the client side TCP connection wait for the FIN from the server side TCP, right? So waiting state, server side TCP, right, is waiting for FIN from this. I think which state it is? This is the FIN which is coming from server side. After send the ACK, which one? FIN wait state 2 is waiting. He is waiting in the FIN wait state 2 to get the FIN from the server. I think answer is FIN wait state 2. Read the problem properly. Simply TCP state diagram, read it. Right? It came already, it came many times. Please take care one time. TCP state diagram, please take care. Now go to the next one. Question number 47. Question number 47. Right? One TCP state diagram is given. Right? So see the S1. Loss of SYN plus ACK from the server. This one. From the server, SYN plus ACK lost happened. Then server will not establish a connection, of course. Without server approver, right? Client cannot establish connection. I think it is true. Loss of ACK from the client. Loss of ACK from the client cannot establish the connection. So when server is asking SYN, client should say ACK. If you don't say also, no problem, because it is a server. Server, client, nothing to give. But ACK should come, right? When client will say SYN, server has to send SYN. Server, sorry, once again I'm repeating. When client says SYN, server compulsory should say ACK. If not, right, connection cannot establish. If server say SYN, client said ACK, perfect. If you don't say, after timer is over, you will take it forcefully. So it is not compulsory. Loss of ACK from the client cannot establish the connection. Need not be. Because server is the superior. Next one. The server moves listen to SYN received to SYN sent. No. SYN received to establish, it will go. S4. The server moves from listen to SYN received to established in the state machine on no packet loss, of course. So answer is S1 and S4 true. Right? It is simple, very simple problem. But remember everyone, when client asks the server, I want to establish connection, server should say ACK. If no ACK, client cannot establish. But another thing is, when server will ask the client SYN, right, sender has to send ACK. If you don't send also, if he lost also, no problem, because server is the highest priority person. You no need of anyone's approval. Casually he will ask. Sometimes Papa will ask casually. Sometimes Papa, Mama will ask the casually something to you. If you say yes also, they will take action. If you say no also, they will take action. Only for namesake they will ask. If you talk more, they will beat you. So my suggestion is, when they are asking something, right, please approve. If you don't approve also, anyhow they will take. If you talk more, they will beat, because they are server. You are eating their food. Right? But right, when you want to do something, you have to take the permission of parents. Otherwise, it's a serious complications. Right? Everyone know this. I hope you got it. Go to the question number 48. Yeah, this is the question number 48. Read one time. Suppose that maximum transmit limit size for a TCP connection is 12,000 byte. Maximum transferable MTU. Maximum transferable unit. Maximum 12,000 bytes. Okay. Each packet consists of 2000 byte. I think MSS. One MSS is 2000 bytes. At some point of time, the connection is in slow start phase. At some point of time, right, he is talking about, carefully everyone listen, he is talking about slow start phase. Each packet consists of, right, 2000 bytes, means 1 MS is 2000 bytes. Slow start phase. MTU is 12,000 bytes. MTU is 12,000 byte. Can you help me? MTU is 12,000 bytes, okay. Then what about threshold? Threshold is 6,000. MTU is 12,000. Threshold is going to be 6,000. Slow start phase. Right? Now let me ask one by one. First he will send. What is the answer? First he will send. Let me check this one. slow start phase with the current transmission window is 4000 bytes. Current is 4000 bytes. So remember, 1 MSS is going to be 2000 bytes. 4000 bytes means 2 MSS. 2 MSS you will send, 2 ACK you will get. After 2, it will become double, right? I think 4 MSS you will send. 4 MSS you will send. Then 4 ACK. Right? That is fine. That's fine. But can you observe this one? 4000 bytes is starting, means 2 MSS you are sending. Subsequently, the transmitter receives 2 ACKs. That is also okay. Assume that no packets are lost and there are no timeouts. What is the maximum possible value of the current transmission window? Right? Here I think 4 MSS is the right current transmission window. 4 MSS means 4 into MSS is 2000 bytes, which is going to be 8000. Answer is 8000. It's a very simple problem. It is a very simple problem. Initially, the terminology, you should know only terminology here. Just is expecting terminology from you. More than that, he is not expecting anything. Just see the terminology. Right? TCP, congestion control techniques. That terminology you have to understand. Initially 2 MSS, how you know it? He said that, right? So in slow start phase with a current transmission window 4000 bytes, which can be written as x into 2000. Means 2 into 2000. 2000 is, right? So can you help Current one is what? 4000 bytes. This can be written as 2 into 2000 bytes, which is nothing but 2 MSS. 1 MSS is 2000 byte. So initially 2 MSS, subsequently 2 ACKs came. In the next round, right, because of it is there in the slow start phase, it will become 4 MSS, 4 ACKs will come. He is asking 4 MSS, right? You have to find out, which is going to be 4 into 1 MSS is going to be 2000 byte, so 8000 byte. Answer for this problem is B. Let's see the question number 49. Until 48 we done. It's a 49. It's a really nice problem, right? Please read one time. Before I will going to give explanation, please you go ahead and you keep the hand inside, right? If you get any mud, I am going to clean. Please go and yourself keep the hand. Right? Check one time. I also tried like that, so I got my hand so dirty, so I revised. I seen the notes and all. I revised, I rectified. What is there in that? Life is like this. Yeah, go ahead. I think it's something related to, right, TCP, UDP. I think we done so many problems like this. But read problem properly. If you do small mistake also, so small tricks are there, you will become victim. I also became victim. I hope I became victim. I hope you will also become victim, so that we both become friends. I already victim of this problem, so I think you will also victim, so that we both will be friends and we both, right, dance on the main road. Yeah, try read properly. I want to say that read properly, otherwise you will become victim. Right? Let's start. See the twists here. UDP datagram containing 8880 bytes of user data. User data means this is without header. UDP without header is this much. And the thing, if you observe clearly, UDP header is 8 bytes. Including header is +8. So total UDP datagram size. When you say datagram, header also will come, but datagram is clearly mentioned user data. Otherwise it could have been datagram means, right, including header. Because of user data, so it became, right, without header. Now you have to add this also. Datagram size is this much. This is the twist here. If anyone take UDP datagram as 8880, then it is wrong. It is 8888. Okay, fine. And MTU size how much? 1500 bytes. And IP header is what? Remember, it is a datagram. Means it is not a packet. It is a datagram. Means still IP header is not added. TCP, right? UDP header is added, but IP header is not added. So what is the MTU size? 1500 bytes. So let's see the rough diagram. So see this one. Everyone careful. 20 plus 8888 coming. It should go inside. MTU is 1500, means 20 plus 1480. So this 20 okay, right? Then what is the answer? 4 8s by 14 8. I think you calculate properly. 6.9 something like that. Approximately 7. Right? So let me do this. That means 1480, right? 20 one packet. 1480 20 one more packet. 1480 20 one more packet. Totally 7 people. Just I'm separating by header. Total how many? 7. So 6. I think one more is there. 1480 20 header. So can you help me now? 1480 into 6 how much? Let's see. 0 6 8 48. 6 4s 24 plus 8 28. 6 I think this much. So left 8 left plus 20. Right? Perfect. I done the calculation. Please check. So right now the thing is whatever it is, it should be multiples of 8. Everyone know it should be multiples of 8, right? So I think it is already multiples of 8 only. How much? I think 8 ones 6 there, 8 8 64, I think 185. Yeah, so the reason is you have to divide by 8. That is the reason it should be multiples of 8. Everyone know this. Everyone know. Now listen everyone. So initial packet offset number is 0. Next one is right, it's 185. It became 185. It became, right, I think 2 185s you have to cross. 2 into 185. This one 3 into 185. This one 4 into 185. It is offset number. This one 5 into 185. It is something like array. 6 into 185. So why 6 into 185? Before 6 people, each of size 185. You have to cross it. Nothing there. This is the way how to calculate the offset number. First one is initially 0. Second one is 1 into 185. How you got that 185? 1480 by 8. Then you got 185. So each of size, right? 185. So second one 1 into 185. Third one 2 into 185. Seventh one 6 into 185, something like that. So if you do that, offset number you will get. So can you see what is the offset number here? Offset number means starting address, starting part. So what is the answer? So 6 5s 30, 6 8 48, so 51, 6 1s I think 11 1 0, right? So 0 is the first person offset, 185 is the next person, 2 into 185 is the next one, so last one is this. So I think if you see the problem, what is asking, there is no option. Okay, right, how many total number of IP fragments will be transmitted? What will be the contents of the offset field in the last fragment? How many is asking? 7. If you don't add, see the small twist here is, if you don't add 8 here, it will become 6 only. Then option A will match. Be careful. then option A will be match. Be careful. So 7 total. Next one is, what is the last offset? Last fragment offset. This one. Right? We are already calculated. So what is the first person offset? 0. Nothing to do, discussion. What is the second one? 1 into 185. What is the third one? 2 into 185. 3 into 185, 4 into 185, 5 into 185, 6 into 185 and so on. I hope everyone is comfortable. So please take care. Last one is this. If anyone asks you, what about sixth one? 5 into 185. How you got this 185? Right? 1480 by 8 you do. You will get the 185. Why are you dividing? That's the reason. These all should be multiples of 8. Because you are dividing. Last one you don't divide. You no need to write last one multiples of 8. Not required. Whatever is there last one, write as it is. Whatever is the last one, write as it is. Because right, there is no need to divide. There is no use of that one. Last person, you no need to do anything. I hope you got. Answer is going to be, I think, third option, right? Perfect. This kind of problems will come. Please take care. So be comfortable with the terminology. UDP datagram containing user data. MTU. UDP header. IP header. It's very confusing if you don't study properly. It is a very confusing if you don't study properly. I am thinking one question will come from this area. Right? Very clear. So in this subject, right? In this subject, it's a very clear. One question will come from this area. IP header, TCP header, right? UDP header. So from this area, MTU, one question you can expect. One question will come from, right? One question will come from sliding window. One question will come from IP addressing, right? Maybe you can expect error control maybe, right? Fine. So I'm thinking, so you are a little bit comfortable with this. Let's go to next one, right? This one. Let's go to next one, right? See this, if you observe properly, I think it is something related to go back by N, sliding window protocol. A to B, you are sending 9 packets. Right? Next one is going to be every 5th packet is missing. Go back by N, where window size is 3. Right? But no ACK from B ever got lost. This is a very tricky question. Go back by N. These kind of problems are tricky. Stop and wait, I think normal. Selective repeat also, these kind of problems are normal. But this is tricky, right? So I will do one time. See correctly? Window size is 3. This is the trap. Please careful. 9 packets. So I'm starting. See everyone, every 5th packet you are losing. Remember. So first packet, second packet, third packet. Remember, window size is 3. Don't think this one that much. Because if you see the go back N, it supports cumulative ACK also, individual ACK also. Right? So individual, how you may say that, right? Let us assume that packets are not coming from the upper layer, right? Fastly they are not coming. They are coming slowly. Then you have to send 111. Even though window size is 3, they are not coming from the upper layer fastly. They are coming slowly. You have to send slowly. And one more thing is, this is the trap, remember. There may be so many reasons. It supports cumulative also, individual also. Be careful. So let's see this one. 1, 2, 3. Right? Fine. It's okay. 4, 5. Every 5th packet is missing. Remember. You want to get maximum retransmissions. What you do is, at this place, because this is anyhow fail. Right? So from here onwards, send the window size. 5, 6, 7 send. Window size is 3. Send it. whichever place fail can happen, from there you send the window size. Remaining all people you send whatever way you want, no problem, because you want maximum retransmissions. If you want maximum retransmissions, from which place fail, that place onward send the window size. So 5 6 7 I sent, so every fifth one fail. So from there you have to retransmit. What is the meaning of go back and all you have to repeat? So 5 6, but remember already 4 over, right? Fifth one 5 6 7, 5 6 7, it is the fifth one, but remember from here onwards send maximum 7 8 9. Wherever fail happened, from there send window size 7 8 9. Now see this one 1 2 3 4, fifth one fail. Because of this reason again repeat 7 8, right? 9. See this one 1 2 3 4 5, again it is the fifth one. From there send maximum, but you have only 9 packets, no maximum, nothing. So 1 only you will send. Then repeat that 9 again. So let's see the final. Let's see in the classroom we done many problems like this. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. 16 is the answer. In the classroom we done these kind of problems many. Please refer the class notes. Yeah, let me try window size is what here 3. Let me try window size 2, right? Let's see 1 2 3 4 5, fifth one it is a fail place only window concept will come. 5 6 fail, 5 6 fail. So what is the answer? 5, right? 5 6 7, right? See this one, window size is 2, right? So window size you don't bother, past time, fail time bother. 5 6, so 5 6 7, right? Until now 4 8, I think windows it is a 5. So now window size will come. So again 8 9 8 9, so I think it's over. So let's see the total 1 2 3 4 5 6 7 8 9 10 11 12 13. Yeah, I think right. So fine. So window size is 3, right? Answer is 16. Window size is 2, answer is 13, right? Be comfortable, let's go to the next problem. Yeah, this problem, see this problem, I think same stop and wait, everything same stop and wait. When you say stop and wait, no window, nothing there, go back and only window there, remaining thing nothing there, right? See this one 1 2 3 4 5, every fifth one fail, right? 1 2 3 4 5, every fifth one fail. Start again 5 6 7 8 9, again fifth one fail, 9. It's normal, whichever fail repeat that only, because it is a stop and wait until it will come. I don't send one more, right? So what is the answer? 1 2 3 4 5 6 7 8 9 10 11, right? I think 5 6 7 8 9 10 11, answer is 11. Same problem, forget about options, same problem I done for stop and wait, right? Same only, whichever failed send, because it is going to be what kind of acknowledgement here? Individual, there is no cumulative here, individual. But go back by n is individual also, cumulative also. That is the reason this problem is interesting. For right, go back by n only. This problem is interesting only for go back n, right? Stop and wait, nothing there. Let's go to this problem. Same thing. I think this is for selective repeat. It is also individual, nothing special. Let me do this. One 1 2 3 4 5, fifth one fail, whichever fail you send it. Any window size, nothing there, even though there no problem, because selective repeat, whichever fail those only repeat. 5 So 5, 6, 7, 8, 9. So 9 again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is also 11 because they are individual ACK, right? But in the case of the go back n, individual also and right cumulative also. If you want maximum retransmissions, fail time go for cumulative, pass time go to individual. Pass time go to individual, fail time go cumulative, you will get the maximum retransmission. That is the trick in the previous problems. So I am saying the trick here. This problem, right? This problem, go back and problem, trick I am saying, trick, pass, go individual. Don't worry about window. Next one, fail times and cumulative. This is the trick you have to follow. Then you will get the maximum retransmission. Max retransmissions you will get. Right? I hope you are comfortable. Let's go to question number. Go back n. I think same go back n. Size is 4. Packets are 9. Window size is 4. Every fifth packet, right? It's a question number 53. Go back and window size 4 here. Remember 4, not window size 3, window size 4. So I will try once, right? 1, 2, 3, 4, 5. Every fifth one fail. Fail time window 5, 6, 7, 8. Window size 4. Cancel. So 6, 7, 8. 5. I think 4 people are over. 6. Again it failed. 6, 7, 8, 9. Right? Now it is fail. So what is the answer? 6, 7. Right? Fifth one failed. So again 7, 8, 9. It's fail. Then what is the answer? Again you write 7, 8, 9. Ninth one fail. So 9 again. 1, 2, 3, 4, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Right? 21. Count properly. 21, right? For your convenience, I think because of different came, I will count once again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 21 is correct, right? Whichever option. If option not there, so go for none of these. So trick I am saying again, pass, send 1, 1, 1. Why are you sending 1, 1, 1? Right? This particular technique is having individual also, cumulative also. Whichever way will give more retransmissions, I will go to that way. Right? Perfect. That is the question number 53. Yeah, problem number 54. Yeah, can you read it? I think some theoretical question, so you can go through it one time. Which is false is asking. Be careful. Which is false. Right? It is possible for a computer to have multiple IP addresses. If I buy multiple IP addresses, my computer also having multiple. Right? You can buy 2 phone numbers. Then right? Then this phone number also will work. That phone number also work. Same way, 2 internet connections you can buy. One computer you can keep. There is no problem. Right? So remember, IP address is unique, but one computer can have many addresses. There is no problem. IP packets from the same source to same destination can take different routes in the network. That is the meaning of dynamic. A to B you want to go, right? So sometimes X path will be given, sometimes Y path given, sometimes Z path given. If you try now, maybe X path will be allocated if it is free. right? If you try after some time, maybe Y is allocated if Y is free that time. So Z, so that is also true. IP ensures that a packet is discarded if it is unable to reach its destination within a given number of hops. I think a TTL value, right? TTL value becomes 0, packet will be discarded, and one ICMP message will be sent. Internet Control Messaging Protocol, right? It will be sent saying that because of so and so reason, I'm discarding your packet. Some reasons also they will say, right? So TTL value, time to leave field, become 0, means it's not possible to find further. Why it is, why that reason, if at all TTL is not there, it may go to infinite loop problem, right? Anyhow, so option C is true. The packet source cannot set the route of an outgoing packets. The route is always determined by only routing tables of intermediate routers, need not be. You want to go from A to B, right? So most probably path is given by intermediate people. Sometimes source also will give. That is called source route option. That is the meaning of in the IP header options field. In the options field, if you set, right, source route option, source only will give path. Strict source route option, strictly whatever source will give, that only you have to follow. That is the meaning of options field in the IP header, TCP header also. So please careful. So this is wrong, that is the reason. Sometimes source also can give. Mostly intermediate people will give, sometimes source also can give. In our real life also, when you are going from, right, your home to, right, your house to somewhere, papa will give path or mama will say path, go this side only, go this path only. This path, if you go, ghost will be there, go this path. If you go that path, right, so many people will kill you, go this path. Most of the time papa only will guide you. That is almost like source route option, right? I think now you are clear. Let's go to next problem, 55. Yeah, it is also, I think, theoretical thing only, which is false is asking. Sometimes in the exam you will play a game, not false. By, right, this is highlight false, not is written small, right? You may think that false. Remember, it is not false. Sometimes you will write not true. Please take care. Please take care this. Anyhow, this problem is false only asking, right? Please, if you read now, I think by seeing problem I can say packet switching, circuit switching. Something differences between packet switching, circuit switching. That's what they are asking. That's what they are asking, right? Let's start now. Let's start. Packet switching leads to better utilization of bandwidth resources than circuit switching. See, so circuit switching dedicated, only he can go, but in the case of packet switching anyone can go. So until these persons, circuit switching means dedicated, you are not giving to other people. Until you will complete, other people cannot go. So packet switching leads to better utilization of bandwidth resources than circuit switching. True. Packet switching results in less variation in delay than circuit switching. I don't think so. There is a clear difference between them. Next one, packet switching requires more per packet processing than circuit switching. In circuit switching, there is no processing because dedicated path is there. In the packet switching, processing is there. This packet should go this path. This packet will go that path. This packet will go this path, this middle. So there is a processing. But in the case of the dedicated one, circuit switching, dedicated one is there, no processing, nothing. Right? This is also true. Packet switching can lead to reordering because of, right, see this one message divided into so many packets. In the case of the packet switching, one packet will go this path, another packet will go this path, another packet will go to that path. I don't know, assume that it is the number 1, number 2, number 3. Out of these 3 people, who come first, I don't know. You have to order also at the receiver. Don't reorder, don't do the ordering at the intermediate. Don't do combine at intermediate. Are you dividing intermediately? Okay. Are you dividing the same thing one more time? So bigger packet you divided. It became small. Again small, you are dividing again. Remember, don't combine intermediately. Combine every time at the end only. This is the very biggest mistake what students will do. Right? So suppose, right, one big packet divided. While going on the transmission, those small packets also again divided. But don't combine intermediately. Combine at the end. Combine at the end only. Divisions will be many times. Combine will be once only at the end. At the end. At the end, right? Reordering will be there. Reordering will be there. Right? Fine. So D also true. So B is the wrong answer. There is a more variation between the delay. In terms of delay, more variation is there. Circuit switching, packet switching, more variation. One is a dedicated path. Another one is not dedicated, so that you can utilize the resources efficiently by many people. So B is the wrong option. I hope you got it.